Hey guys, I hope you guys are having a good day today. This video is for Algebra 2 NTI for days 27, 28, 29, and 30. So on days 27 and 28, you are doing the same thing on those 2 days. And there is some vocabulary on there that you need to know what it means. But really what the question is asking you to do is pretty simple. So the question is wanting you to find the degree of a polynomial, and this is just some random example that I made. There are some on the day 27 that explain it really clearly. I'm just doing an extra one here. So in this example, my degree is 5. The degree is your biggest exponent. It should be the very first one that is in your polynomial, because you do want the polynomial to always be in standard form, going from the biggest exponent first down to the smallest one. So you can see this one starts with the exponent of 5, then the next smallest 4, then the next smallest 3, then the next smallest 2, and then we're missing just a single x term with the exponent of 1, and the last one is just the coefficient, which actually has exponent x to the 0 power. So the exponent would be 0 on the x, just a constant term. So when we're talking about the degree of the polynomial, we're just looking at that very first one. We're looking at that biggest exponent is the degree. So that degree tells us a couple things about the polynomial without having to look at it on the graph. It tells us how many total zeros there are, and you're going to see later that there are several different types of zeros, but for these 4 days, the main ones that you're going to be talking about are the real and the non-real. So that helps make up that total zeros. However many zeros a polynomial has is based on that degree. It's going to be the exact same. So this one has 5 total zeros. When we were in school and we were looking at those quadratic functions, remember those have a biggest exponent of 2. Those always had 2 zeros because that was the biggest exponent too. All right, the last thing it's asking for on days 27 and 28 is the maximum number of turning points. So a turning point, and it does tell you there on your paper, is when your graph is changing directions. So this graph actually has 1, 2 turning points. This graph has just 1 turning point. Okay, so to know the maximum number of turning points, you take your degree and you just subtract 1 from it. So 5 minus 1, 4. So that says this graph could have 4 turning points. It doesn't have to have 4 turning points, but it could have 4 and no more. It could have less than 4, but it can't have any more than 4. So 4 turns would look, let's see, 1, 2, 3, 4. Something like that. The graph turns here 1 time, here again, second time, a third time here, and a 4th time here. So that's a possible example of what that graph could look like with a maximum of 4 turning points. Okay, so 3 big things on days 27 and 28. Degree, biggest exponent. Total zeros, it's the same as your degree. Your maximum number of turning points, your degree minus 1. When you get on to days 29 and 30, you have to not only look at the equation here, but you also have to look at the graph, because for those 2 days, you were trying to take a look at what kind of zeros we're seeing. So we have real zeros and we have non-real zeros. And we've talked about both of these things before. We've talked about those non-real numbers, which have the I in them. That's the same thing for the non-real zeros. They're going to have that little I that looks like that. So our real zeros, you saw this on days 25 and 26. That's anytime the graph is crossing the x-axis. So the graph does cross the x-axis here and here. So it has 2 real zeros. Remember that if the graph does just kind of glide up against the x-axis, so let's see, let me add that down here. Let me switch colors. All right, so if you see something like this, and this graph just glides up against the x-axis right there, that really counts 2 times. So if you ever see that, you have to count it twice. This one where it goes through is just going to count 1 time. So we have 1 and then 2, 3. We would have 3 real zeros with something like that. All right, so anyway, back to our problem. We found the number of real zeros by looking at when it crosses the x-axis. To get the non-real zeros, we also need to make sure we know the total zeros. And that's just like what we did on days 27 and 28. The total zeros is by the degree, my biggest exponent, which in this one is 4. So my total zeros are 4. If I have 2 real and there are 4 total, then I only have 2 left over to be the non-real zeros. Your non-real zeros do come in pairs, and we're not going to see them on the graph. So we're not looking like, you know, this isn't a non-real zero or any like this isn't. That's not what that means, although that is a min, and that's another min, and that's a max. But we don't look on the graph to find the non-real zeros. We just take our total minus the real ones, 4 minus 2, to give us 2 non-real. They do come in pairs of complex conjugates. So, for example, like 1 0 could be 5i, and the other one would have to be negative 5i because they're conjugates. Or like 2 plus 3i, and its conjugate would be 2 minus 3i. Okay, you're never going to have 1 non-real zero. You're never going to have 3 non-real zeros. You're never going to have 5 non-real zeros because they have to come in pairs. So you will always have an even number of non-real zeros, or it is possible to have 0 non-real zeros. Okay, if your total zeros is the same as your real zeros, there aren't any non-real zeros. Hope this helped you on NTI Days 27 through 30. See you guys.